Another lecture. I'd like to give you an overview of Kotlin. It's nice to understand some of the basics, maybe give you a little information about some of the goals of Kotlin, and try to have you understand why you want to use Kotlin. So traditionally, Java was the language that you used to create Android applications. It's been like this since Android's been around 2008, 2009. You can also use C++ to create Android applications, but those are the native libraries. Java is a hybrid language that is both compiled and interpreted. When you write your Java source code files, they're in .java files, and you use the javac command to compile the source code, and what happens is new files are created called .class files. This is the compilation part of Java. A compiler will check the Java language for syntax errors, and if there's any errors, it will display them. Otherwise, it will generate these class files. This is referred to as bytecode. Once you have the bytecode, you then run an interpreter, which is the Java virtual machine. The Java virtual machine interprets the class files. And this is what allows Java to be portable across many platforms. One of the big advantages of Java when it first came out back in the early 90s is that you could write it once and you could run it on Unix, you could run it on Linux, you could run it on Windows. It didn't matter the platform, you only had to write it once. And with other languages, this isn't the case. If you write C code, you have to write it on Unix with a particular compiler, and then if you write it on Windows, you may have to change things so that it can run on a Windows operating system. So Java has this hybrid approach that is both compiled and interpreted. It's an extremely popular language. It's used for everything. I'm sure you have heard of it. It's used on web page development, embedded systems, standalone apps, to mobile apps, and that's what we're going to concentrate in this class. We're going to concentrate on mobile application development. However, the Android platform mainly supports features from Java 6. Currently, the current version of Java out is Java 8. Java 6 is a bit old. It's 2 versions below, and as a result, it doesn't have a lot of modern language features. It doesn't have this concept of lambdas, which we're going to talk about a lot. It doesn't have many other things as well. It's more of an older language, and it's very tedious to write some Java code. There's a lot of wasteful code. When you write an Android app, you end up writing a lot of code over and over and over again because you're required to do it, and it's just not fun to write Java code in an Android app. So, since Java uses JVM, the Java Virtual Machine, this allows developers to create Android applications with any language that generates bytecode. And some other languages out there that generate bytecode are Groovy, Scalar, and Clojure. The big one that we're going to obviously study in this class is Kotlin. Kotlin, it will run on the JVM, so that means we can use it to write our Android applications. It's a JVM-based language developed by JetBrains. JetBrains is the company behind the IntelliJ IDE. It was developed in about 2011. It's been around for a while, but just recently Android is recognizing Kotlin as a first-class language. It's supporting the language fully, and that's one of the reasons I created the class, because it's going to become a major component of Android. So you want to learn it as quick as you can. It was created with Java developers in mind, and with IntelliJ as its main development environment. So the source code is normally stored in files with the extension .kt. So like Java files have .java, Kotlin files have .kt. And because it was created with IntelliJ as the main development environment, we get all the great benefits of this great IDE, just like Android Studio. The most common areas to use Kotlin are server-side code, which we're not going to concentrate in this class, backends of web applications, the server-side applications you could write in PHP or Python. You could also write the applications in Kotlin. They're also going to be used a lot now on Android devices and Android mobile applications. Again, because now it's a first-class language and it's a lot of fun to use, and it's very, very efficient. It's very intuitive and easy to learn. The learning curve is very low. It's an expressive, concise, extensible, safe, pragmatic, and focused on interoperability with Java code. And we're going to talk more about that in the coming slides. But these are really the goals of Kotlin. The designers kept in mind all the issues that they had with Java and designed it to be expressive, concise, extendable, and so forth. So Kotlin can do everything Java can do with less code and fewer annoyances along the way. And at the end of this lecture, I'm going to give you an example of that less code, mainly with the data classes. Very, very minimal amount of code compared to Java. It's also super fun to read and write Kotlin code. Now that you don't have to do all these tedious things in Java with Android development, it's more enjoyable to write the code in Kotlin. It's just more fun. You don't have this wasteful activities where you're just copying and pasting boilerplate code. The goals of Kotlin we just mentioned, and what these goals mean are, Kotlin has a goal of being pragmatic. And what that means is the language is practical and designed to solve real-world problems. Its design is based on many years of industry experience. Its features are chosen to address common issues and complaints encountered by many software developers. So focus on features and solutions that have already appeared in other programming languages and have proven to be successful. It greatly reduces the complexity of the language and makes it easier to learn by letting you rely on familiar concepts. So the pragmatic part of Kotlin is very, very important. Another aspect of Kotlin's pragmatism is its focus on the IDE and why IntelliJ was chosen. The tools will automatically detect common code problems, patterns that can be replaced by more concise constructs, and offers to fix the code for you. So with the IntelliSense that's built into IntelliJ and all of the common errors, it does a lot for you. Just like when you use Android Studio and you have a red circle around an error, you can right-click on it and it will say, import this package, fix this problem, create an anonymous inner class, for example, for Java. For Kotlin, it will do the same things. And this is very, very important. It's practical. Common problems should not take a long time to fix. You should be able to easily select something in the IDE to have automatically be fixed for you. It increases your efficiency, reduces your time to write the code. So it's very practical in terms of the chosen IDE. It's concise. Very often developers spend more time reading existing code than writing the new code. And this is just a fact, especially when it's not your code. If you have to write additional code, you have to study it and you have to understand what it is. And if the language is harder to follow or it's just very verbose, you're going to, again, it's about efficiency. You're not going to be able to write as much code. So you have to read a lot of code to find out what you have to do. The simpler and more concise the code is, the faster you're going to understand it, and the easier it is to be able to add additional code or fix bugs. So concise code takes less time to write and, more importantly, less time to read. Kotlin's excellent design and expressive names increase the ability to understand the code. So this is the concept of meaningful names. It looks very English-like when you read it, and even non-programmers can follow it somewhat because of the descriptive names. The syntax clearly expresses the intent of the code you read and doesn't obscure it with boilerplate required to specify how the intent is accomplished. It's very, very intuitive. So a lot of the standard Java boilerplates, such as getters and setters, and the logic for assigning constructor parameters to fields is implicit in Kotlin. Kotlin has a standard library that lets you replace these long, repetitive sections of code with library method calls. And that's very, very apparent when you do a find view by ID in Android. You don't have to do that. It's just much smaller. And you have to typically do that on every onCreate call in Android. You have to get all your resources and you have to do multiple find view by IDs. With Kotlin, a lot of that goes away. And again, I'll give you an example of this at the end of the lecture when we use a data class. The getters and the setters can automatically be generated by Kotlin. You don't have to provide all that boilerplate code. It's safe. And what safe means is its design prevents certain kinds of errors in a program. Now, we know that you're going to have bugs in your program. No language or compiler can prevent all possible errors, especially logic errors. But Kotlin does a much better job than Java. There is a trade-off between the level of safety you get and the loss of productivity required to put in more detailed annotations. So what happens when you try to make a language more safe is you tend to add more things that the runtime system can know about, the JVM can know about. So you have to provide more information to the JVM. And when you do that, you may lose out on performance, because if you have to have more data, more runtime information, it can decrease the performance. And if you decrease performance, then that's not a good thing. So you have to have a trade-off here. You want to be more productive, but you also don't want to decrease performance. You can increase the productivity by having this safe operations. But Kotlin does a great job of managing this trade-off. There's a high level of safety in Java and a small overall cost. So although that Kotlin has these concepts of nullability and things like that, it doesn't cost the performance. It doesn't impact performance much. So Kotlin ensures the type safety of your applications. We're going to talk about static typing and compiler checks, but Kotlin will infer types automatically. In Java, you have to declare data types that are associated with variables, int, float, double. In Kotlin, you don't always have to do this. Depending on the data that you assign to the variable, the compiler will automatically understand the data type. So this type inference is a big deal, and you're going to notice that when we start writing some code. And also, type safety is automatically checked by the compiler because of the statically typed language. It also, and this is a big deal, it handles nullability much better than Java. A big problem with Java is that you have null pointer exceptions and you have to check for them. Well, Kotlin strives to remove that problem from your program. It has a type system that tracks the values that can and can't be null and forbids operations that can lead to a null pointer exception at runtime. And I'm going to show you how to do this in examples, but this is a huge deal. You don't have to worry about your program crashing at runtime because something's null, an object is null. Most of the things that are built into Kotlin will do this checking automatically for you. There's operators that you can use that can do this for you, but mainly the type system just doesn't allow you to have null pointers. It will give you compiler errors. Interoperability, another big, huge deal that Kotlin provides. It's very easy to get started using Kotlin because of its interoperability with Java on Android. Now, if the Android or whoever designed Kotlin, IntelliJ engineers, if they decided, hey, we're going to write our own language, it's not going to work with Java, it wouldn't be used as widely. It'd be everybody would have to ditch Java immediately for Android apps and go straight to Kotlin and learn it. Well, the designers are pretty smart because they made Kotlin available with Java interchangeably. You can keep your existing code, continue to use the various Android libraries, and incrementally add Kotlin code to your project. Over time, you can learn Kotlin. If you're not a Kotlin expert, you can start writing a little Kotlin code here and there with your Java code in an Android app. And then over time, you can add more and more as you realize how great the language is and how less tedious it is than Java, you can adapt it fully. But Java and Kotlin can coexist. They can mix their source files. It doesn't matter about the dependencies. It doesn't matter about anything. You can write Java code and Kotlin code in an Android app and it will compile and run. It's a drop-in replacement. You can call into the Java language from Kotlin and you can call into Kotlin from the Java language. So vice versa, mixing the code. Very beneficial, and again, allows you to learn the language at a slower pace, as well as maybe you like Java in certain instances better. You use Java sometimes, use Kotlin the other times. Maybe you don't like some features of Kotlin that you don't want to use as much. You don't have to. You can use the Java language as well. So Kotlin classes and methods can be called exactly like regular Java classes and methods. You don't have to learn new things here. It gives you the ultimate flexibility in mixing Java and Kotlin code anywhere in your Android project. You can also extend Java libraries. This is the concept of extensions, and this is huge. This allows you, Java libraries and the Java APIs, you can never extend them, right? You would just use them. Kotlin doesn't have, so an example would be Kotlin doesn't have its own collections library. Collections are a framework in the Java API that allow you to store data. Using generics, you can store any type of data, linked lists, array lists, maps and sets, and you can reuse this functionality from the API. Well, if you want to add new functionality to those classes, you can do that in Kotlin by extending the collections API. So it's a really nice feature that you can use in Kotlin. It makes things much more convenient. These are the goals of Kotlin. At this point, I want to just show you an example of how Kotlin is so expressive, and also how you can write a lot less code with Kotlin versus Java. So I don't have, we haven't learned about the IntelliJ IDE, so I'm just bringing up Notepad++ here and showing you an example of some Java code. This may look familiar, it may not. Don't worry about it. But here's a Java class called artist. A class is defining an object, and we'll get to all that stuff. We have some member variables here, long ID, string name, so forth, and then we have get and set methods. Get and set methods are traditional, something that you traditionally include in class to provide for encapsulation. And we have all these get and set methods. You'll see that there's quite a bit of code here. Get sets, and then you also have a toString method and so forth. About 47 lines of code. You can do this exact same thing in Kotlin in roughly 5 lines of code. So with Kotlin, all you have to do is create a data class. Here's a data class called artist. It has 4 member variables just like the other class in the previous example. Right? We just had 4 member variables, and that's all it has. So this can show you the simplicity of Kotlin and all the boilerplate code that you do not have to write. Kotlin knows how to auto-generate all the get and setters that you would have to add manually in Java. It's also will automatically inherit some of the methods that are based off the base class of object. In Kotlin, it's not an object class, but it's an ini class. But you can automatically get the equals hash code methods in the toString method for free. You noticed earlier in this example, you had a toString method. You don't even have to put that implicitly inside the class for Kotlin. You automatically get it. So again, this isn't going to necessarily make sense, but it should illustrate to you that, wow, there's a lot less code with Kotlin, and you can do a lot more. The language does a lot more for you. You don't have to tediously add all this boilerplate code. So as we go through the course, we're going to provide a lot of examples of Kotlin's goals, and everything we discussed here, it will become a lot more clear. But hopefully this was a good introduction of just what Kotlin is, what its goals are. We'll talk about some of the advantages of Kotlin and some of the other language features of Kotlin in other lectures. Thank you.